Hi, I'm Matthew Palco, and today I'm here with Eric Donner, and we are both PMs from the enterprise and security team at Microsoft, working on identity protection and credential protection. And so today we're going to be talking about what's new in Windows when it comes to identity security and some of our passwordless investments. During the talk, we're going to be talking about, like I said, what's new with passwordless, and then we'll also be spending some time covering Active Directory authentication. So mainly Eric will be covering that first section around passwordless, and then I'll be covering some of our on-premises investments that we've been making. And then finally, we'll have a section where we can cover any questions that you all have. And with that, I'm going to hand it off to Eric, who's going to start with some of the passwordless changes that we've been making in Windows.
Thanks, Matthew. My name is Eric Donner. I own the passwordless journey within the Windows client. So what does that mean for you? It means how do we go passwordless with Windows in general? So starting off, Microsoft has been on a passwordless journey for a long time, working to address the risks that passwords pose to our customers. We process trillions of security signals each day, which have shown us that there are thousands of passwords attacks occurring every second. In the last year alone, we've seen an increase of 1,000 password attacks a second to over 4,000 password attacks a second. We have been partnering with others across the industry as part of the FIDO Alliance to develop usable, secure replacements for passwords, which is now culminating in the integration of passkeys across the industry and the OS platforms. Last month, Microsoft made an announcement to integrate passkeys in Windows 11 22H2 at the Microsoft AI and Surface event on September 21st. You may all have also seen blogs from Vasu Jakal, CVP of Security, Compliance, Identity, and Management, and David Weston, VP. David Weston's highlighted these updates. To showcase these passkeys recently, GitHub, which we worked with very closely on announcing their support for passkeys and their integration in the overall passkey world. To start this off, let's take a step back and answer a question of what is a passkey. Simply put, they're a replacement for passwords that are more secure, easier, and faster method to sign into websites and applications. They're phishing-resistant credentials based on WebAuthn. They're consumer-friendly, yet enterprise-grade, and can be leveraged as either device-bound or across all the devices within your platform ecosystem. Passkeys, like other passwordless investments, are built into the FIDO2 set of standards. This means that it builds on the previous work we have shipped in earlier releases of Windows to support features like passwordless sign-in for Entra ID, join devices, and with security keys. Today, we follow the web browser stack to go through where a website or an application calls into the W3C WebAuthn API, which calls into the FIDO platform and the Client to Authenticator Protocol, CTAP. In the past, we've only enabled this for physical security keys, and it's been hidden behind a Windows device. But with Windows 11 22H2, we're starting to move it towards being more front and center within Windows, and to be able to use it across device authentication on your phone or your tablet. Using a phone requires scanning your QR code, which will establish a connection to your device. Ensures that you are in proximity to your device, and so that credentials can be passed back and forth or recognize that they're back and forth. You can then follow the instructions on the device to save the passkey or use the passkey. If you have an Android device that is linked to Windows, it is possible to connect to it without using the QR code if the device is in proximity, simply enabling Bluetooth. Similarly, once connected to the device, you can follow the instructions on the device to save or use that passkey.
And Eric, you talked a little bit about the Windows support, and that also is using some of our biometric experiences and built-in experiences too as well. Can you talk a little bit about that?
Absolutely. Windows Hello is our passwordless solution within Windows. Windows Hello leverages your biometrics that are natively integrated into your device. So you can use your camera, your fingerprint, a device pin to unlock Windows Hello. And once you've unlocked Windows Hello, that's where you store your passkeys. With the support of passkeys, we wanted to recognize that not everybody understands exactly what they are. While we have a lot of folks who are very tech savvy and want to dive into them very deeply, we also looked at those who may not understand exactly what they are and are a little hesitant to use them. So what we wanted to do is make it very clear to people that passkeys are on their device and that they can be managed by themselves. With Windows support for passkeys, we've also added these controls in the settings and applications that can be used to manage your keys. If you navigate to the accounts page and passkeys on the bottom, you'll open up the following page on the right here. This presents a list of passkeys saved on your Windows device, including a domain name and user account associated with that domain. Through this UI, a user can go through and delete a passkey and remove it from their device if they need to. These device-bound passkeys are then once removed and are no longer available on the device.
Yeah, I remember we used to have to delete every key. So this is really great that you can do it individually now. And this is only for our platform ones, right?
Correct. On device-bound passkeys today, you can go through and you can delete them individually. You're absolutely right. Before, you had to go through and get rid of the entire container, so it was a one-shot all. So you could only delete all of them or individual ones. So now you have the granularity to go through and say, hey, I just want to delete maybe that Home Depot one or just that other live account one. In this case, it gives you the flexibility you need to be able to kind of continue forward and continue not basically shooting yourself in the foot. In addition to that, with Windows 11 22H2, Windows Hello and the consumer passwords have supported making an account passwordless for some time, allowing users to completely remove passwords for their Microsoft account and remove the password login from the logon screen. Now, on the consumer side, we saw a great uptick on Windows 11 for people going in this route. The enterprise side has just started to come. And so on the enterprise side now, on the commercial side, we've been making the investments to catch up here a bit. In 2021, Entra ID and Azure AD at the time introduced temporary access pass to address a major gap in our passwordless story, bootstrapping. Being able to sign into a device for the first time, whether during an out-of-box experience or from the lock screen in a passwordless manner. Today, we open up a window called Web Sign-In, which is a feature that we just recently released and allowed a web authentication dialog on the lock screen. This dialog has been restricted to temporary access pass in the past, but is now being expanded to allow other authentication mechanisms that would be available to users. So for example, if you have a phone sign-in setup, users can passwordlessly sign in using their Authenticator app. Password plus MFA is also an option for those not enrolled in the phone auth to ensure that the sign-in is done using MFA credential. And using the web sign-in is not enabled by default, but still requires a policy configuration to be used, but is fairly simple once working on it.
No, I was going to say, this improvement's really great because I know, especially with recovery flows, if you had to go through the temporary access pass route, that was pretty restrictive because admin has to go and control all that. So now having the flexibility to use any of these auth methods you've already set up is a really great improvement to that user experience and end user experience.
Yeah. One of our common goals is making sure that things are not only more secure, but also user-friendly. We can only hit that bar if we balance both of them. So, but in addition to, improving the capabilities for website, the team also invested in reliability of it as well. So the pin reset experience made a strong investment in making it more reliable, more robust, making people easily capable of leveraging it. In the September update, that experience has been improved to address those issues to make sure that they can do either recovery or setup on the device at the lock screen.
Yeah, I remember going through that when I used to work on Windows Hello for Business as well, and I'd try to do pin reset, and then it would just toss me back on the lock screen. And so it's really great that with these changes, we have better reliability there, better user experience, and users shouldn't experience that type of pain.
Absolutely, absolutely. And in the September update of Windows 11, we have new dedicated controls enabling this passwordless experience for being introduced in Entra ID joined devices. These experiences are still not supported on hybrid Entra ID joined devices or on domain joined. Once you move to the cloud, these new controls are available through MDM and Intune and can be configured from the settings catalog under the authentication category. It's also possible to configure the settings using a custom URI, but it makes it a lot easier for our admins to be able to manage it that way too. This new option provides more flexibility to users. It disables the legacy password enablement, but doesn't block other areas in where users might need to use a password if prompted. But it helps users go down the path of leveraging Windows Hello biometrics, pins, and security keys, the more passwordless alternatives. When using this policy, we do recommend that you do not configure the credential provider to filtering policy to filter out passwords or other credential providers in case needed down the line. This is a huge step forward for those folks who have already gone and started our passwordless journey and are just waiting for that last mile to be able to start moving people away from passwords even more so. Now onto what's new in Windows Authentication. Matthew, want to tell us a little bit about the work you guys are doing?
Yeah, thanks, Eric. So there's a lot of different things that we've been doing within more on-premise authentication. Eric talked a lot about some of the things on the Entra ID side that we've been doing. There are a lot of customers that are still hybrid and that still have an on-prem presence. And so we want to make sure that authentication within that space also continues to remain secure and that we're making investments in our fundamentals there. So there's a few areas that I'm going to talk about. One around some default hardening that we're doing, and then some fundamentals improvements that we're doing when it comes to authentication in this space. So the first area I want to talk about is password theft and the removal of wdigest SSO support from Windows. And this is something that's available in Insiders today. So the way Windows Logon works, which is kind of shown in this diagram on the right, is that you have a credential provider. And so we have a password one as an example here. The user types in their password there, and that's going to get, the actual password will get passed from that cred prob to the Win Logon service, and then to the local security authority on Windows. And what LSA does is it will pass the password to any of these different security support providers that are actually components that implement different authentication protocols within Windows. So those blue boxes that I have in the LSA box are examples of those. So Cloud AP is used for Entra ID auth, Kerberos and NTLM are used for authentication with a domain controller. And then we also have this WDigest one. And so this is a legacy authentication protocol that actually requires providing a clear text password as part of the protocol. And when we originally implemented it, we also added SSO support so that when you log into Windows, we can take your password, pass it to WDigest, and then any services that are using that protocol can use your logon creds. So somewhat of a good user experience, but it has had security implications. So WDigest can be abused by attackers to basically harvest your plaintext password, because when we pass it to this provider, that plaintext password needs to be cached within LSA. So attackers that want to go and dump LSA memory can then steal your plaintext password. And so previously, this SSO component was controlled by a registry key that you could go, and by default, this was turned off. So in Server 2012 R2 and Windows 8.1, we disabled SSO by default. But we've actually seen attackers will go, they'll turn on this policy, and then they will trick users into signing in or force a sign in, and then rehydrate the password in this cache. So it's not enough to just kind of disable it at this point, which is why we're going ahead and removing that SSO component. WDigest as a protocol does have some legitimate use cases, particularly when it comes to security over IP devices, like video over IP. But in those cases, you're typically using a supplied password that's specific to that device. So we don't need to use your logon cred. So WDigest as a protocol will continue to be in Windows to support those use cases, but we're removing SSO as a disclosure vector. So another area that we are default hardening is the LSA process. So we've had an existing feature called Local Security Authority Protection that we've enabled in Windows, and in Windows 11 22H2, we actually enabled this by default for new installs of 22H2 that are enterprise joined, so Entra ID joined or domain joined. And we did that for compatibility reasons, because we didn't want to break applications that load into LSA. But now we're actually going to go ahead and expand that functionality. And what we've done is we've actually, we'll be expanding this to enable LSA protection on upgrade for both consumer and enterprise devices. So the way this will work is on upgrade, LSA protection enters evaluation mode. We will be checking for processes trying to load DLLs into LSA. And so if we don't detect any loads during that period, we will actually enable LSA protection on your next reboot. If we do detect loads, we will flag that, and then we won't enable by default, because we want to make sure that we can maintain compatibility with any applications that you may have that need to load into LSA for legitimate reasons. If after this default enablement evaluation period is over, you want to go enable LSA protection or turn it off if it was default enabled, we've actually gone ahead and added some UI to do that. So this is in Windows Security under the Device Security Core Isolation page. And so there's now a Local Security Authority Protection section, which you can toggle on and off to control the feature state. If you're an enterprise managed device and there's policy set to manage this setting, it'll override any user control. So this will actually be grayed out, and will, of course, respect that enterprise policy. Another thing that we've added is compatibility notifications. So we worked with the Windows Compat team to implement this. And so when LSA protection is on, if there is a DLL that tries to load into LSA and we block that, then we'll go ahead and flag a notification that lets you know that we did block that load, and then it will provide information about the module that we tried to load. So if you're an admin, you can go ahead and use this to determine if there's any applications in your environment that are going to be problematic if you try to deploy this more widely. Or if you're an end user, you can go and look at these modules to see if there's any applications you might have that are having problems because of LSA protection. And we have seen a lot of benign cases of this where there's some processes that will try to inject into every service host on Windows. It'll also try to load into LSA. Those are cases where you could dismiss this and leave LSA protection on, for example. But we did want to provide this as a tool so you have more information to know about what is potentially being blocked. All right, so the next area I'm going to talk about is some changes that we've made to the Kerberos protocol in Windows. So there's some fundamental improvements and then some functionality improvements that I'll be going through. Kerberos is the default authentication protocol on-prem for AD authentication. So it is really important for us to continue to make investments there. So the first thing I want to talk about is some of the cryptography improvements we've been making. To talk about that a little bit, I'm going to first kind of introduce some core concepts. So this shows a flow of really how Kerberos works. So you have a client, you have the thing that you're proving who you are to, which is the KDC, which is typically a domain controller. And then you have a thing that you care about. So an application server, it could be a SQL server, it could be an SMB file share. But what really happens within the Kerberos protocol is there's going to be 3 round trips. The first one being, steps 1 and 2, where as the client, I'm authenticating to the KDC and proving who I am. Then I'm going to, in steps 3 and 4, request tickets from the KDC to the service that I want to access. And then I'll use those tickets in steps 5 and 6 to then prove who I am to that service and then start making service requests. The thing that I wanted to point out is that throughout all of those back and forth, there's a bunch of different keys that we use to encrypt messages as a part of these flows to make sure that your credentials can't be stolen as a part of this and that messages are secure. So we have client-derived keys that are known by your client and your KDC. There's session keys that we'll use as a part of encrypting messages between the client and the KDC. We'll also have, client-server session keys so we can securely talk between the client and the application server. And so all of these keys, we need to make sure that all of the cryptography that we're doing with these keys is up to date and it provides secure messaging. So that's an area that we've been investing. So first, we've been moving AES as the default encryption algorithm instead of RC4 for all of our symmetric crypto that we do within that messaging. And so now we only will use RC4 if it's explicitly required by a service and you have to go and configure that. Another thing that we've been doing is updating the encryption algorithms that we support. So today in 22H2, we only support AES SHA-1. In Insiders, we've now gone ahead and added support for SHA-2. And so the specific algorithms I have listed here. And then we've also been making infrastructure changes to add some crypto agility functionality, which will make it easier for us to add more ciphers in the future. So if we need to go, add something past AES in the future, we can do that in a much easier manner. And then another thing that I want to call out is server-side support for public key cryptography for initial authentication, or PKInit. And so PKInit is basically what we use when you want to authenticate with an X509 cert, with Windows Slow for Business, or with a smart card to your domain controller and do Kerberos. And today that only supports SHA-1 in our GA builds of Windows. So we've actually added client support for SHA-2 in Windows 11 22H2, but we are now adding server support, which is available in Insiders. So if you have both an updated client and a server doing PKInit, we'll use SHA-2 by default. So that will apply to our passwordless mechanisms using PKInit, so specifically Windows Slow for Business, but it will also apply to things like Smart Card. So in addition to some of those cryptography improvements, we're also making functional improvements because we want to address some of the gaps where Kerberos can't be used today and is actually falling back to NTLM. It's a big goal of ours to move all on-prem authentication to Kerberos. And we've recently announced some blogs that talk about our strategy of reducing NTLM usage. And we've had some public talks about that, which cover some of the same material. And I recommend you go and view some of those, which we'll talk about in more detail. But we really want to address some of the functionality gaps that we have in Kerberos. So the first one I want to focus on is what happens when you have a client and it wants to talk to the KDC, but it doesn't have line of sight and it can't communicate. This makes up about 5% of all NTLM usage today. It's an important use case for us to address. So in this example, if we do have line of sight between the client and the application server, and the application server can talk to the KDC, we're implementing new functionality called IA-Kerb, which is an industry standard protocol, which allows us to use that application server as a proxy. And so we can send messages from the client over that application server to the KDC and go through all of those round trips I talked about earlier. So you can do that to, prove who the client is to the KDC and get service tickets and then complete normal Kerberos auth with those service tickets. And because of all the cryptography I talked about earlier, all these messages that will be passed over the application server proxy are, encrypted and will continue to be secure, which really allows us to go down this path. The other functionality gap that is even more significant is what happens if you don't have a KDC because you're not on-prem. What about local users and workgroup authentication? So in that case, this makes up about 29% of all NTLM usage. And so it is also a really important scenario for us to address. And so in that case, what we're doing is we're actually going to implement a local KDC on all machines. And so this is going to be built on the local SAM in Windows. And so if you have a client and an application server that both have a local KDC, we'll now be able to do Kerberos between that client and application server without your domain controller in the picture. So this will allow us to move local account authentication scenario off of NTLM to Kerberos. And the way we're actually implementing IA-Kerb and local KDC is through another protocol called SBNego or Negotiate. And so typically when an application wants to use Kerberos, they don't actually call Kerberos directly. They'll use the Negotiate protocol so the client and the server can negotiate which authentication protocol they want to use. So today, with the updates with local KDC and IA-Kerb, we'll still try to use Kerberos first, but then when that fails, we'll then try to do IA-Kerb. And then if it's a non-domain scenario, we'll then leverage local KDC through our IA-Kerb path. And then finally, if all of this fails, we can still fall back to NTLM through the Negotiate protocol. And so that's something we'll continue to support as we go down this journey of, fixing these Kerberos gaps and removing NTLM usage for Windows. So that fallback will continue to be something that we support. All right, so I want to do a quick wrap up of some of those features that we talked about and also highlight which ones are actually in Windows today and which ones are coming. So all of the stuff that Eric talked about earlier about passkey integration into Windows and the WebAuthn enhancements, all of that is now available in Windows 11 22H2. The Kerberos AES defaults that I talk about are also available in Windows 11 22H2. Most of the other on-premises authentication investments that I talked about are coming in Windows 11. So those are available mostly in Insiders today. So LSA protection on upgrade that I talked about and WDigest SSO removal, those are available in Insiders builds. The Kerberos cryptographic improvements are also available, but the IA-Kerb and local KDC support and then some other work that we're doing around NTLM will be available in Insiders soon. So keep a lookout for more notifications from us about those changes so you can go and test those out. That wraps up our presentation today. We'd like to thank you for your time learning about the new investments we've been making in Passwordless and authentication and identity in Windows. Thank you again for joining.